Our session today will look at demand and supply analysis. In the previous sessions, we dominated so much on demand. So just a quick recap, demand we defined as the quantity of a good or service that our consumers are both willing and able to buy at different prices, where supply, on the other hand, is a quantity of a good or service that suppliers or producers are willing and able to sell at different prices during a given period. And market equilibrium is simply a point where demand equals supply. So demand is downsloping, looks like this. Supply is upsloping, it looks like this. And equilibrium is the intersection of the two. So this is what we call the market demand. Market demand is simply a point that occurs where the quantity demanded is equal to a quantity supplied at a particular point. So the importance of understanding this is that managers and policymakers will be able to be given informed decisions at a particular time. So it is important for um, decision making. So we also looked at the law of demand and the demand analysis. That what does the law of demand stipulate? That holding all things constant, an increase in price will be accompanied by a reduction in quantity demanded. So it has an inverse relationship. So if you increase your price from P1 to P2, your quantity demanded will reduce from Q1 to Q2. So we looked at factors that affect demand. We say that there are several factors that affect demand, which are the price of the good, the consumer income, the related goods, the taste and preferences. So the relationship is inverse. This is what makes the slope to be negative. So if you're going to have the inverse demand function, it's given by A minus BQ, whereas A is the intercept where it's cutting the p-axis. This is called our A. And our slope is the gradient. So this is our B, which is a slope. So the movement of um, prices from A to B is a movement along the demand curve. Okay. So the movement from here to here is uh, along. So from point A to point B, this is a movement along. This is only when the price of that particular good is affected. So if other factors like income, price of related goods, tests, they all constitute a shift. A shift. Okay. So they all constitute a shift. And we also looked at price elasticity of demand yesterday. What is price elasticity of demand? Price elasticity of demand is simply the responsiveness of um, demand due to changes in the price, due to changes in income, due to changes in other factors like population, etc. So elasticity of demand, we said if it's greater than 1, it is elastic. So meaning the quantity responds more proportionally. So if you increase by 1 kwacha, you lose demand by more than 1 kwacha. Then if it's equal to 1, it is unit. It's proportional response. So if you're going to increase by 10%, you're losing demand by 10%. Then if it is less than 1, it is inelastic, meaning the quantity responds less proportionally. So we looked at point elasticity of demand, which is at a particular point. So the formula for point elasticity of demand is elasticity QD, it's the Q over dP times price over quantity at that particular point. Okay. So point elasticity of demand is important because you're able to calculate the elasticity of demand at a particular point. So elasticity of demand for direct demand, we say if you have um, demand which is 10 minus 2p, what is the point elasticity of demand when the price is 4 kwacha or 3 kwacha? So we need to find the corresponding quantity. So when you put the price 3 in there, our Q therefore will be 10 minus what? 6, meaning the Q will be 4. The B is the gradient, the slope of, or the number that comes before the letter. Our B in this case will be what? Minus 2. So the point elasticity of demand is given by dq over dp times price over quantity at that particular point. So if you haven't learned calculus, the derivative of q with respect is simply the gradient here. Our gradient here is what? Our b. So b times price over quantity. So this is what we call the point elasticity of demand. So our b is what? 2, negative. So this is negative 2. Then our price is 3, and our quantity is 4. So 2 times 3 is 6. 1 times 1 is 4. So 6 over 4 is negative 1.5. So 1.5 is more than 1. So we can say it is what? Elastic. Elasticity of demand is elastic. All right. So this is what we call point elasticity of demand. We also mentioned that elasticity of demand can be inverse if the subject formula is what? Is P. So P minus 3Q. So here, suppose that we are given our Q as a 1. So meaning when you put the Q as 1 there, it will be 10 minus 3, which is the P7. Our B is simply the gradient there. Our gradient there is what? Negative 3. So elasticity, since it's an inverse demand, elasticity for the inverse demand is simply 1 over dP over dQ times price over quantity. Or the gradient here, we simply say our elasticity is simply 1 over B times price over quantity. So our B in this case is what? Minus 3. So 1 over minus 3. And our price is 7. And our quantity is 1. So 7 over 3 is negative 2.33. So our comment there will still be demand is elastic. Demand is elastic. So we also have what is called arc price elasticity. Arc price elasticity is simply the elasticity that looks at a range of prices. What happens from this point to that point? Okay, it measures elasticity within particular range of prices. So if you are looking for elasticity within a certain range, we call it arc price. It's important to also know the range within which will still remain inelastic or elastic. So when dealing with arc price elasticity, basically we are looking at the average responsiveness of quantity demanded to changes in price over a specific range of what? Of prices, rather than at a single point. It is very useful where you have a large changes in prices and quantity if you want to provide more accurate information than at a point. So the formula is Q2 minus Q1 over Q2 plus Q1 divided by 2 divided by price 2 minus price 1 plus price 2 as price 1 over 2. So if you are given, for instance, the price elasticity, the price of bread increases from 10 kwacha to uh, 15 kwacha, causing the quantities of demand to reduce from 20 units to 10 units. So what is the arc price elasticity? So arc price elasticity is therefore equal to what is our Q2 minus Q1. So 10 minus 20 over 10 plus 20 divided by 2. Everything over P2. What is our P2 there? 15 minus 10 over 15 plus 10 over 2. So top here we're going to have negative 10. This is 30 over 2, which is 15. Then here we have 5. Then this is 35 over 2, which is what? 17.5. So 10 over 15 is 0.6667 negative. Then 5 divided by 17.5 is what? 0.28. 2857. So 0.667 divided by this answer, we're going to get negative 2.33. So at 2.33, we can simply say demand is elastic. Demand is elastic. So any questions at this point before we proceed? Are we together?
Yes, we are following.
You're following, okay. So if you're following, we can now uh, we can go to the exam question. Okay. So we go to the exam question here. We want to try. Consider an equation where 25 minus 3p where Q represents what demanded. Calculate the arc price elasticity when P1 is 4 and P2 is 3. Okay. What do we do? Who wants to try? Are you using the question? Is it any strange from what we have just talked about? So we use those quantities to generate you use those prices to generate the quantities, right? So let us use the values that we have. It's question number 4. Okay. You can go to the pamphlet. Question number 4, we're given demand 0.5 minus 3p. So using the arc at $4 and $3, when you substitute that, at $4, our quantity will be 13, and at $3, our quantity will be 16. So we have P1, Q1, P2, Q2. So using the formula, we just substitute in there. So we're going to find our arc elasticity as negative 0.724. So we say this is inelastic. All right, inelastic. Is that clear? Are we following? It's straightforward, isn't it?
Yes, it is.
Then we go to the arc price, then calculate the point elasticity at these prices, and is demand elastic and inelastic at these prices. So the point elasticity is simply the elasticity at specific points. Like we had indicated in the preamble, point is simply at a particular specific point. So we have the equation that has been given initially. So our equation was what? So what do we identify from here? What is our B? From here, what is our B? Our B is what? Negative 3, isn't it? So the point elasticity, we established that the first point is P1 is 4 and Q1 is 13. Okay, so if we're going to use this one here, P1 is what? 4, Q1 is what? 13. So what is the point elasticity? Is B times price over quantity. What is our B? Negative 3. And what is our price? 4. And our quantity is 13. So 12 over 13. What do we get as the final answer? We're going to get negative 0.923. Negative 0.923. What is our comment here? Inelastic. Anything starting with 0 is inelastic. Here, our P2 was what? 3, and our Q2 was what? 16. So our point elasticity, same procedure. We're going to have what? Negative 3 times price is what? 3 over Q, which is 16. So 9 over 16, it is going to give us what? 0 point what? 0.5625. 5625. Okay, so what is our comment? Demand is also inelastic. They are all less than 1. Right. We'll go to the next question. Next question is asking us, if anything, what can you say about the relationship between arc price elasticity of demand and the total revenue at those prices? The relationship between arc price elasticity of demand and the total revenue. And also, the next question is asking us to establish what is the price elasticity of demand at the price that maximizes total revenue. At the price that maximizes total revenue. So maximize total revenue. What can you say about the elasticity of demand? Okay, so let's start with the relationship. Firstly, the elasticity to maximize revenue. You maximize revenue when TR is differentiated. The revenue is maximum when marginal revenue is equal to zero. So I'm going to teach you calculus at a later point, but you must make P subject and you equate to zero, then you find the elasticity. So you need to find the inverse demand here. When this one comes aside, and this one comes aside, so we're going to have what? 3P is equal to 25 minus Q. So divide by 3 here, divide by 3 here, there's a 1 there, divide by 3 there. So P is equal to 8.33 minus 1 over 3 Q. Then the marginal revenue, just multiply this one by 2. Marginal revenue is equal to 8.33. That's a shortcut. Minus 2 over 3 Q. Then when you get this to 0, this one will come this side. So when you have 2 over 3 Q, go to 8.33. Okay. So when you divide that, we're going to get our Q is equal to 12.5. This 12.5 is what you put in here to find your P. Anyway, I'll explain that one at a later time when we look at calculus. But we must understand the relationship between what? Total revenue and elasticity. What is the relationship? So relationship is that when demand is inelastic, a decrease in price will lead into a decrease in total revenue. So the percentage increase in quantity demanded is smaller than the percentage decrease in price. So this is also consistent in our calculation where we found that the price fell from $4 to $3, where the total revenue changed from 4 times 13, which was 52, to 3 times 16, which was 58. So total revenue decreased, which aligns with the rule for inelastic demand. Then price elasticity of demand at the price that maximizes the revenue. So when price is maximized, whatever question you do, as long as you're maximizing revenue, unit demand is unit elastic. So this is a point where any further price change or decrease, that is an increase, would also lead to a decrease in total revenue. So you usually have unit elasticity. For anytime you are maximizing total revenue, you have unit elasticity. That is our general rule, and that is what happens. Okay, so elasticity of demand, you're usually going to have a unit elastic demand. So my next session will be to take you through how we maximize, optimize revenue and profit. So I'm going to end here for now. I'll send you the videos for the class now. I also send you videos for um, revenue maximization so that you go through on your own for our next class. Thank you so much for your time and here.